Hey there, Nick Genethakis here. In this video, we're going to go over signing and verifying Git commits on the command line, as well as go over how to modify your GitHub account so that you get this verified badge next to your name every single time you push up a signed commit or a tag. This signing process is done using a GPG key pair. That's just how Git signing works. So you will need a GPG key pair to do this. If you don't have one, that's no problem. I just put up a card now that goes to a video I created not too long ago about creating your own GPG key pair. If you already have one, then you are good to go. Also, as an aside here, if you happen to be using GitLab or Bitbucket, then it all works the same here. They have slightly different instructions on how to link up your GPG key to your GitHub account or GitLab or whatever, but most of the stuff is all the same. So let's get to it here. And by the way, the end game is going to be adding a couple of options to our gitconfig file, but let's not do that by default yet and go over how to manually sign your commits and tags, because there is a subtle difference when it comes to tagging that's not going to be immediately obvious right away. So for that, I'm gonna just screw around here in an empty Git repo. You don't need to follow along with this stuff if you don't want to, because we're gonna throw away this repo at the end. But if you do want to follow along, no problem. So let's initialize a new Git repo, and I guess we'll touch a new file first, and then add that file, and then commit things like usual, right? We can do initial commit. This is stuff you've probably done a million times, right? And then we can do a git log and there is our commit. Great, cool. So now let's go over touching the second file here, and we'll add this file, and we'll do a git commit just like we did before, but this time we will add a -S here, which is going to assign the commit, and then we'll put in a message here of second commit. And then we can do a git log just like before, and now we have two commits. Although on the surface, these commits look pretty similar. Can't really tell which one is signed and which one isn't. So for that, we can actually do show signature here. And here we can see all sorts of great information about the signed commit. We can see it's a verified signature. It's a good signature from whoever signed it. In that case, that's me. In your case, if you're using your GPG key pair, then this information is going to change. Now, you might be wondering, well, what's the real value in signing a Git commit? And the problem with Git is, and it's not really a problem, it's just due to the nature of how it works. Let's say I make a new file here, and I add this file, and I commit this file, unsigned by the way, and I use the author flag, and I just say maybe today I'm Elon Musk, right? So I don't know his email, let's just say example.com or something like that. And and I just say I'm smart, trust me. And if we do a git log now, let me clear that just so we have a full screen. Suddenly my author is Elon Musk. So, imagine if this is some code for something with a rocket ship, right? You don't want to have me committing rocket ship code, that's for sure. So signed commits are really nice because you can actually verify that the person creating the commit is that person, and that signature validation process happens through your GPG key pair. But before we get into the details about that a little bit more, let's go over working with Git tags. So, I'm sure you've done this a million times as well, right? You can just do git tag v1, and then you can do git show v1, and there's the tag that we created. This is called a lightweight tag. It's really just a pointer to a specific commit. There's no other information saved with that tag. But you can also make annotated tags, right? You can do this and maybe put it in a message of whatever, it doesn't really matter. And we'll just make a new tag here that's annotated. And if we do show on v2 there, then suddenly we get this metadata or, object data about this tag, right? We have the tagger, the date, the message, and, the tag name and stuff like that. We can even choose not to put in any message at all and still make an annotated tag. And then, if we do a git show here on v3, then, we get the same information, but no message. And the reason this is really important is when you create a signed tag, you can't create a lightweight tag like we can with the v1. So let's do git tag here -s, by the way, is how you make a signed tag. I don't know why it's lowercase instead of uppercase. Maybe uppercase S was already taken for tag before signed tags were a thing. Not really sure, but let's make a v4 here. So it's just not going to let us create a lightweight tag. We're going to have to put in some message here. And if we don't put in a message, then it's going to fail. And it's going to be hey buddy, you have to put in a message. So we can choose to either put in a message like that, or the other one, we can do M here and put in cool, that's going to totally work. We can also choose to even do an empty message, suddenly that works as well. I guess there's a difference between an empty string annotated tag versus an unannotated tag. I guess that's a difference between the two. But if we do a git show here on the fourth one that we just messed around with here, then, we do get the PGP signature as part of this data here in the tag. That's why it needs to be annotated. So You can also verify a tag by doing a get tag on the tag itself, and then you can do -v, and that will just give you, similar output to what we saw when we did show signature with the git log, right? We have good signature from Nick, so you can verify your tag. Cool. So that is how you can sign your commits and sign your tags, but I'm sure you've already been thinking about this for now. Like when you do a git commit and you put in -s, it's super easy to forget to do that, especially if you're not used to signing your commits. Because for me, I have not been signing my commits for a long time. I've had a GPG key pair for, I don't know, like 6 years, but signing my git commits started pretty recently. And I just don't want to have to be on the hook for typing this out all the time. So lucky for us, if you take a look here at your git config file, and by the way, I have like a .user, which is a different pattern slightly. So my main git config file actually includes this file. And the idea there is this user config could be ignored from version control, and it has like personal information in there, like about my name and email. Again, the stuff is public, so I don't need to like blur it out, but my .dot files are basically public on GitHub. Like this, I have a git config here, but also a config user. Like you're meant to copy in this one and then, modify these things on your own and copy it over to your home directory and not commit it to version control. But going back to here, so yeah, we can just basically uncomment all of these lines and things will be auto-signed for both commits and tags. So for the commit one, just GPG sign true. And for the tag one, same deal, but capital S. And then for the signing key, this is like, well, this one's important too, but this needs to match up to your actual GPG key pair ID, the email address that you used when you created your GPG key. So if I do GPG list keys here, then it's going to be this email address for me. It's going to be different for you, but that's the one that you want to pop in here for this signing key. Alternatively, you can put in like a key ID, but the email address I think is just easier to read. Now, this one is a little bit interesting because if I go back to the comments here, this actually requires having Git 2.23 to work. Otherwise, if you don't have this, if you have like a lesser version of Git, then you will need to remember to put in -s every time you want to sign your tags. You can also choose not to sign your tags as well. That's no problem. And by the way, if you're wondering, if you're running like something like Ubuntu 20.04, then if you do a Git version, you're good to go. It's 2.25, I think. Yeah, 2.251. So if you're using an older version than 2.23, then you can choose to upgrade your Git version using whatever package manager that you have, or just deal with like not signing your tags, or again, just put the -s yourself. So that gets you going for being able to sign stuff automatically. So if I jump back to here and I touch another file here and I add this one and I commit this one, is like, cool, it works, like I hope. Then if I do a git log here with show signature, then cool, it works is not actually signed. What did I do wrong? So let me go back to here. Oh, look at that. I forgot to save the file. Aha. So let me go back to here, touch a new file. There we go. Git add this one, git commit. Cool, it works for real this time, I hope. And then I'll do a git log, or actually let me clear this first just so it doesn't get bumped down too far. There we go. Cool, it works for real. I don't know how many times I commit something and I'm like, fix CI for whatever, and then it's like, 11 commits later, it actually works. But in any case, we are good to go now, right? Our signature is all set up. Nice. So let's get going on how we can have this set up on GitHub. It's not too complicated, thankfully. So if I go back to over here, and then you'll probably remember this command from the previous video about creating a GPG key pair. So you can run GPG, and then you can do export armor to get like a text output of this. And you can put in your ID, right, your email address here. And that is going to just dump out your public key. But we don't just want to dump it out there. Like you could do that and copy it manually. But if you're using WSL2, you can also just pipe that right into clip.exe, and now it's in your clipboard. If not, you can just dump it out and copy it manually with the mouse or whatever, or like PB copy or whatever if you're using Mac OS, or on native Linux, I don't know, it's like xclip command, I don't know it offhand. But in any case, like your clipboard is copied, or your key is copied to your clipboard. Also, I need to zoom out a little bit. Now, what you want to do is go to your GitHub settings, and then jump over to your SSH and GPG keys, and then you can just add a new key here. So what's interesting here is, it just tells you exactly what you need to paste in, right? This key here. I'm not going to do it because I already have it done. But what I was saying before about the thing that's interesting is GitHub is only going to let you import keys that have an email address that matches your actual account email address. So that is really, really, really important, because if I were to generate a new GPG key pair saying I'm like really Elon Musk or something like that, and I put in like his real email or whatever, then suddenly I'm getting like verified commits by him when I'm not him. So GitHub was pretty smart to do that. I don't know what Bitbucket or GitLab does, but we are going to go over how to actually manually validate these things on the command line, so we're not dependent on GitHub or like another Git provider, like being able to do this type of validation with the email matching. But in any case, like if you're using GitHub, then you should be good to go now, right? You just added your key, and the next time maybe you can set up like a private repo just to test it out, but you should see that verified badge and you're actually all good to go. But now let's go over, how to do this manual validation process, because it's a little bit, I don't want to say like hard to do, but there's a lot of moving parts, sort of, kind of. So notice here from the source signature, right? Like this good signature, like how does it know that it's good? And it knows that it's good because if I go to, let me just start closing some of these things out here. If I go back to here, if I do GPG list keys, the reason how it knows it's good is because my key is in my keyring. So if you wanted to actually verify that someone who did the commit is actually like a good signature, you're going to need their public key in your keyring. Now, in that GPG key pair video that I created previously, I didn't really go over the remote aspects of GPG keys. So you can actually push your keys up to it's not a central server, but like a server on the internet, and kind of gets propagated around. And then you can also pull down and search for keys from others. So check this out. If I do a GPG, I don't run these commands often, so I'm looking at some notes here. Yeah, so like search keys. If I search for this key, next-gen attackers, and you can actually do this on your own. This is just doing a lookup on the internet for this key. It should return a result pretty quickly. Did I spell anything? Oh, it's not email. Okay. Gmail. There we go. And also, yeah, whatever. Let me just rerun it just so it's not getting blocked. We can see that the GPG command, by default, is going to use this key server. A key server is basically a server on the internet that uses, whatever this protocol, then this is where the key is stored. I don't know the low-level details about how all of this works. It's sort of, I think, kind of how DNS works, where it eventually gets propagated around, but there's no like central source. So it's not like if you use a different key server, your key might not be in there if you do a check. But this SKS one is very popular. It's what GPG uses by default. So you should totally use that one, if you want to share your keys with someone or exchange them, basically. But yeah, okay, so we searched for this key, we found it. Your key probably isn't in there yet, so you may want to push it up there. I'll go over that in a minute. But what's really important here is this. So this ID next to the key here, like you'll want to copy that to the clipboard. Like let's say you want to import my public key, right? That's what we're going to do now. And then you can just delete it after. I'll show you that in a second. So instead of doing search keys, now you can do receive keys, and then you can paste in that key, or maybe it's just receive key. Let me look here. It's okay. So it's receive keys like that. Cool. So we have this ID here and you can just run it. In my case, like my public key is already in there, but you should get probably similar output. And now if you were to run GPG list keys, then you're going to see your key and my key as well, hopefully. And there you go. Like you just, downloaded or have my public key in your GPG keyring. And now like if you wanted to verify that commits were actually made by me, then you'd be able to, run like a sort of signature, like assuming that you had my commits on your disk, like, if I push them up to GitHub and you pull them down, then you'll be able to see that it's a good signature. If this didn't match up, like if someone made their own GPG key and they actually used my name and information like this, then, I don't know the exact message that would happen, but it wouldn't be a good signature because it wouldn't match because, this signature, it's related to like, I guess my private key as well, right? But that's not pushed up anywhere, but it's, I guess when I push the key up, that information, I guess, is in the public key enough to know that like the fingerprint or whatever lines up. I don't know the super details about that. I don't want to fumble around it and make pretend that I do. But all I know is like this is the process. So in addition to, searching for keys and receiving keys and listing keys, you can also delete keys as well. So you can do GPG, delete keys, and then you can actually just put in an email address, and then that is going to delete keys. And by the way, okay, so you probably won't see this one if you actually try to delete my key because, I don't want to delete my key. That's my key. So it actually tries to protect you from yourself, thankfully, where you need to use a different flag if you actually want to delete like your entire like private and public key pair. But normally if you're just deleting someone else's publicly, like if I had someone else's key in there, then this would have worked fine. But yeah, there's no way I'm going to run that one because that's going to actually like really delete my private key as well. You should never run that unless you really want to delete your private key. But as for uploading your key to a key server, you can do GPG and then you can do send keys. There we go. And in this case though, you won't be able to just send up like your email address because technically your email address, there could be multiple keys in there. So before you actually run send keys, sorry about that. Again, like this is not something I do all the time. There is a way for you to do list keys and you can put in a different key format. So you can do key format long and then put in something like, you know, your email address, not mine this time. And key ID format, what did I miss? Oh yeah, list keys, dashes, cool. So notice how now there is this D2 address or ID number. This is the one that you'll want to copy, right, from your key. And then you'll be able to do that GPG send keys and pop that in and you are good to go. So that actually just sent it over to this key server. This is a very important thing to do. Like if you were to update the expiration date of your key, then you should be sending your keys with this one command here. I did not cover that in that other video about creating a GPG key pair. Didn't really come up in that video, but for this one, it is important. But yeah, that's how you can share your keys between two people. There's actually other ways as well. Remember that command that we ran before about the export command for Armor, and then we got our key like this, right? And this is from that other video where if you do this, then we have the public key. You can also choose to output that out, right, to a different file. Like you can just do out and then, I don't know, like hello.gpg.pub or whatever. Like, well, you probably should put like your name there. But when you do that, then you have this hello key here. If you didn't want to use a public key server to exchange your keys, you can actually just have whoever you want to import into your keyring give you their public key like this. You can tell them, hey, run this command and then like email me this file or like whatever you want to do. And then what you could do is you can just run GPG and then import, and then you can just import their public key like that. And there we go. It's very similar how we ran the received keys command that imported it from the key server, but now it's like a local import. So that's how you can basically do this, you know, without requiring a central key server. So I believe that is everything related to being able to get other people's public keys so you can verify stuff. But now maybe we can go over protecting yourself a little bit from like merging in code that's unverified by accident. So right now we are in this master branch here, but let's say that we had, I don't know, like a different branch here called like feature, like something, like it doesn't really matter, right? And we touch another file in here and then we add it and then we commit it. And then there we go. And like if we do our usual, okay, I just commit my public key as well. That's not a big deal at all. But you know, let's say that we have this feature branch. Like let's say that you pull down one of your repos from GitHub on your machine, and it includes like a pull request from someone or whatever. It doesn't even have to be GitHub. It could be from Bitbucket, like whatever, right? The Git repo is on your machine at this point. So what you could do at this point, right, is you can do a checkout master, and then you can do a git merge, and you can do a verify signatures. And by the way, also you can do -s here to actually sign this merge as well, like instead of signing your commit or a tag. To be honest, I'm not sure if this one is necessary based on having the config option for commits. Like we have auto sign set for commits, but not merges. I don't know if there's a separate config option for merge. If there is, you may want to put it in. This is not something I do a ton, so I don't have it in my config file. But in any case, we can merge in our branch now, which is feature something. And there we go. Like we just merged it, but we also verified that all verified signatures need to actually be verified. And if we do a get log in here and we do show signature, then there we go. We have that feature that we just basically merge into master. It's all good. So this will kind of protect you. This command here will protect you from merging in unverified commits, which could be really important if you're accepting work from the internet. So I think that is pretty much all of it. I don't know how long this video is so far, almost 20 minutes, but it pretty much covers everything you'll need to know, at least in your day-to-day, maybe the 90% for assigning your own commits. A lot of the stuff at the end is really just for verifying commits, if you're like a repo owner, if you really want to make sure that anyone who's contributing has actually made the commits that they have. If not, then really it's like a 2-minute thing, right? You just modify your git config to have those options that we looked at before. You know, this one over here. Yeah, git config user, right? Blah, blah, blah. Yeah, as long as you have these, then that's all you need from like a committer's perspective. I hope this helps you get going for signing your commits. If you like the video, please like it because it helps a lot with the YouTube algorithm. Also, if you have any questions about this, I'll do my best to answer them in the comments below, so don't be shy about asking questions. On that note, thanks a lot for watching, and I will see you in the next video.